Hello everybody and welcome to the review session for Exam 1. What I'm going to be doing here is going through each of the chapters 1 through 5, going through the PowerPoint slides, talking about the stuff that I think is important, telling you stuff that is for sure going to be on the exam, a few things, although not very many for this first exam, that will definitely not be on the exam. In exams 2 and 3, there's going to be a few more things where we cover it in lecture and you might have homework questions over it, but it's not something I'm going to test you over. There's not going to be as much here because everything we're doing in exam 1 is very foundational. Everything we're doing here is what's going to be built on for later stuff. So there's not going to be as much stuff here that you don't need to worry about, but there will be definitely quite a few things that are of absolute importance that I will stress, and I will tell you for sure there will be questions like this, or there will be questions over this topic. And that will be the video that we're going to go through today. So we're just going to start out here in chapters 1 and 2. Here at the beginning is just kind of an introduction to chemistry. I'm not going to test you over this stuff here. Like I said, it's just an introduction. There's not really material for testing over until we get to the scientific method here. So the scientific method, there could be some fairly straightforward questions over the scientific method, nothing super abstract or in-depth. Possibly something like explaining the difference between a hypothesis and a theory, for example. So a hypothesis would be based on one observation. You see something and you hypothesize as to why that thing that you saw happened. Whereas the theory is built on lots and lots of observations and lots of hypotheses and testing. So just kind of very basic, explaining the difference between the different steps of the scientific method. Chapter 2 is where it really gets going. So jumping right in here with scientific notation. I won't give you any questions on the exam that are only scientific notation questions. So I won't give you a question where I just say, you know, here's this number, write it in scientific notation, or what would it be in scientific notation. I'm fairly limited in what I can do with Blackboard questions. And so even if I wanted to do that, I'm not even sure I could. That being said, you need to be able to read scientific notation because I will put questions on the exam that might have numbers in scientific notation. And so if I put something in the exam like 5.12 times 10 to the 8, you need to be able to read that and understand what it's saying. So you won't necessarily be writing them or going back and forth, but you need to be able to see scientific notation and understand it. By the way, this is as good a time as any to talk about when you're putting scientific notation into Blackboard. So if, for example, I ask you a question, and this is the answer you get, which is this number here. You get a really big number. You could just type it into Blackboard just like this, and that would be perfectly fine. To put in all the zeros and everything, that's perfectly fine. If you would rather do it in scientific notation, the way Blackboard works is very much like a TI calculator. So if you were going to type this in scientific notation in Blackboard, you would do 5.12 capital E and then 8. So the capital E is times 10 raised to whatever you put next. So the engineering exponent is what that's called. And so it's just a shorthand version of writing the times 10 raised to, and then whatever you put next is the exponent there. So if you want to put this into Blackboard, that's how you would do it. But if you prefer to write the whole thing out, that's perfectly fine. I just find this way easier. Alright, so this is talking more about scientific notation. Sig figs. There will be at least one question about sig figs on the exam, probably 2, maybe even 3 questions on sig figs on the exam. And the way that I will ask those questions will be something along the lines of what is going on here on this slide, where I give you some relatively simple math equation to solve. So it should be fairly easy to solve the math. The goal is not to see if you can solve the equation. The goal will be you need to input the answer with exactly the correct number of sig figs. So normally in my classes, I'm not a big stickler on sig figs. As long as you are within 1 or 2 of what the sig figs should be, I don't count off points. I might make a note of it, but I won't take points off. But for these questions where the entire point of the question is the sig figs, I will indeed take off some points, or will at the very least not give you full credit. You'll lose most of the credit since the whole point of the question is the sig figs. If you get significantly off, especially. If you're just 1 off, then maybe you won't lose all that much. But anyway, the point of those questions is the sig figs, and so you really need to be exactly correct with the sig figs on those questions. All right, so talking about exact numbers versus measured numbers, you should know the difference between those two things. So exact numbers, these have essentially infinite sig figs. This is where there's no uncertainty, there's no doubt about what the number is. So this is when we count discrete objects like pennies, or if we have a defined value like a conversion factor like the one shown there. Whereas measured values, there's always some amount of uncertainty, and so sig figs have to be used. So this whole section through here is all about units and unit conversions, which is often called dimensional analysis. So these unit conversions, converting one value into the same value but with a different unit, there will for sure be quite a few questions over dimensional analysis on the exam. There will be, I would guess, 5+ questions on the exam with varying complexity on these questions. Some of them will be really straightforward. It might just be like this one here. This is relatively straightforward, or even more straightforward like this one. So that's even more simple, where it's just you're going from kilometers to meters, so that it is a single conversion factor dimensional analysis problem. Other ones are a little more in-depth, so like something down here where it's one conversion factor, but you have to use it 3 times because it is a unit cubed. So there'll be some variation when it comes to those. But there will for sure be 5, 6 questions or so that is just dimensional analysis. Maybe even more than that, just depending on how simple some of them are. Normally in an on-paper exam, I would have just one question over this, but it would be in multiple parts. So I usually have it as question number 1 on the exam, and then there'd be parts A, B, C, D, and so on. So the way Blackboard doesn't really let me do it that way. Every single one has to be its own question. So the question number, the total questions on the exam tends to get inflated because of that, because every single question, even if it's just a little yes or no, is a whole question. So anyway, there'll be at least 5 or 6 questions where you'll be doing a unit conversion like we do here in these slides. And I know I've talked to a few of you about this, but for those of you that I haven't talked to about this or been sending emails about this, if you're struggling with the dimensional analysis, one thing I would suggest is going to my General Chemistry 1 videos. So that's the Chem 1315 playlist on the YouTube site. And in Chapter 1, I don't have the videos labeled with the names, but you can look around in the Chapter 1 videos. I go through the dimensional analysis there as well. And I go a little bit more in depth in that class because some of the conversions we do are a bit more detailed. They have a bit more going on, and so I go into a bit more depth. Plus, I have a little bit more time in that class because we don't have to cover quite as much material in terms of the raw number of chapters in that class. We cover a lot of stuff in this class, and we just don't have time to go into depth as much on some of those. So if you want to get a little bit more in-depth view of the dimensional analysis, I would suggest looking at the Chem 13-15 Chapter 1 videos. At the very least, it'll give you a few different example problems to look at. Density, kind of the same thing here. You should definitely know how to use density. I will have at least one question, and probably only one question. If it's a really if I put really simple questions on, I might put two really simple density questions, but probably just one density question will be on the exam. So the thing you need to be able to do with those is just make sure you know how to convert between grams and mass. Between grams and milliliters, or more accurately, mass and volume. Be able to convert between mass and volume using the density. The density is essentially a unit conversion factor, allowing you to convert between mass and volume. So make sure that you can do essentially anything we do on this slide. If you can do everything on this slide without too much trouble, you should be pretty well prepared for anything I would put on the exam. Okay. Let's move on to Chapter 3. This is where we talked about matter and energy. So we're going to start out here with the different phases and just generally describing the phases. You should be able to note the differences between different phases of matter, between gas, liquid, and solid especially, but you should also just know very generally what a plasma is. As far as classifying matter here, there will be at least one question, and actually, now that I think about it, it's going to be kind of the same thing with this one as it was with the dimensional analysis. Normally, on one of my paper exams, I would have one question and I would give 3 or 4 different things for you to classify into one of these 4 broad categories here. But again, because I'm kind of limited as to how I can write questions in Blackboard, it will probably be 4 individual questions, where there's just, here's a thing, classify it as one of these 4 categories. So you should definitely be able to classify things as either elements, compounds, homogeneous mixtures, or heterogeneous mixtures. There will be questions on the exam asking you to do that. And by the way, just because I say there'll be 4 questions, and I don't know, I might not end up doing 4. Don't think that I'm saying that because, oh, that means there's going to be 1 of each. No, that's not how it works. The way that it works is I write, I don't know, maybe 10 or a dozen or so questions, and then I tell Blackboard to give every student 4 random ones from the whole group. So if I write, a dozen different questions and 4 of them happen to be elements, if you're really lucky or unlucky, depending on how you look at it, Blackboard could decide to pick all 4 of those elements, and so you could get all 4 of them are the same thing. It is truly just random which ones you'll get. So don't think, oh man, the last 3 I saw were elements. Surely this one's not an element. No, it's the luck of the draw when it comes to those things. Same type of thing with physical and chemical properties. There will be at least one question on the exam where I describe a property or tell you a property, and you have to tell me if that is a physical or a chemical property of that matter. Just to remind you, physical properties, these are things that are displayed without changing the composition of the material. And chemical properties you have to actually chemically change the material to display that chemical property. Okay, so this is just kind of introducing you to the idea of chemical reactions. I do expect you to understand the concept of conservation of mass. I know there were a few questions on the homework about this as well, but I do expect you to be able to figure out, if you have 4 things involved in a reaction, you know exactly what mass you started with, and you know one of the products, you should be able to figure out what mass of the other product is. You should be able to use the concept of conservation of mass to do that. Alright, so then the last thing here is energy. I'm not going to test you over these, you don't need to memorize the definitions of these different types of energy. This is just kind of an introduction to energy here. I do expect you to be able to do unit conversions using these different energy values. So you should be able to convert between calories and joules, as well as between kilocalories or food calories and joules, or kilowatt hours for that matter, but I'll mostly stick to the calories and joules. And by the way, I think I mentioned this in the video as well, but I will not try to trick you with lowercase c and uppercase c. Technically speaking, uppercase c means one thing and lowercase c means something else. If I intend for you to be doing something with a food calorie, I will say food calorie. I will not have an uppercase c and just, expect you to catch that. It will say food calorie. As far as exothermic and endothermic, the main thing is just understanding the difference between the two. So if I describe a process to you, you should be able to tell me if it is exothermic or endothermic. So if energy is being released, that would be exothermic. If energy is being absorbed, or sorry, did I say endothermic? If energy is being released, that is exothermic. If energy is being absorbed, that would be endothermic. So just knowing in general the difference between these two things. And lastly here, you should be able to use this equation, which we'll get to in just a second. There it is. This equation using the specific heat capacity to solve essentially for any part of this equation. So I would give you enough information to find the other 3 parts, and you should be able to solve for the unknown, whichever one I may pick. And there will be a question on the exam, at least one, probably just one, but at least one question on the exam where you will need to use this equation and solve for one part or another. So maybe I give you enough information, I give you the mass and the specific heat capacity, and I tell you the starting and ending temperatures, and you have to solve for the heat. Or maybe we say, we don't know what this material is, but we did these measurements and we found the heat, the mass, and the change in temperature, and you have to solve for the specific heat capacity. Like something like that. You'll have to solve for one of the 4 parts. Alright, so that is chapter 3. Chapter 4, we start off here with history. So we go through some history of chemistry. You do not need to have the different parts of the atomic theory and the nuclear theory memorized, but what I do expect you to know is that the atomic theory was Dalton's theory, and I expect you to know that the nuclear theory was proposed by Rutherford. So those are the 2 history things that I might test you on. Those would be nice, easy, true-false questions. So Dalton had the atomic theory, Rutherford had the nuclear theory. Alright, so now we're getting into the building blocks of the atom. Any of these values here, by the way, like the masses of protons, neutrons, electrons, their charge, you don't need to memorize those. If at some point you need them, which you shouldn't, I have no intention of writing a question where you would need those, but just to So you know, rest easy. If at some point for some reason you did need those, I would give them to you. Under no circumstance will I require you to memorize any of those masses. I do not have those memorized, and I've been doing this for a very long time. So no worries there. I do expect you to know that like charges repel and opposite charges attract each other. And now we're getting into the periodic table. I do expect you to know that the atomic number, which are these numbers here on top, I expect you to know that that is the number of protons that every atom of that element has. So that is the definition of that element, is the number of protons. As far as the periodicity here of the periodic table, really all I'm expecting you to know in terms of the different regions of the table and why everything is arranged the way it is, I just expect you to know that these are the metals, and these are the nonmetals, and then the metalloids are in between. I will try to make it blatantly obvious if you're dealing with a nonmetal or if you're dealing with a metal. I won't come in and like pick something here that's right on the line to be like, is antimony a metal or a metalloid or a nonmetal? Like I won't ask questions like that because most periodic tables don't have them labeled like this, and I don't expect you to have those memorized, other than just knowing that the metals are in the bottom left, the nonmetals are in the top right, and the metalloids are in between. That is the extent of it. Alright, so we're just talking about the different groups on the periodic table. I do expect you to have the names of these different groups memorized, and there's really just four. They're just these main four ones that I expect you to know. So I expect you to know that everything in group 1 is an alkali metal. Everything in group 2 is an alkali earth metal. By the way, sometimes written alkaline earth. And I think this one actually might even be more prevalent, alkaline earth. But it means the same thing. The main thing is just if it has the earth in there, it's telling you it's in the second column. Group 7, or 17, that is the halogens, and then the noble gases. So it's these four columns here. I expect you to know the names for those. So again, alkali metals, alkali earth, halogens, and noble gases. So again, that could be a nice, easy, true-false question. Bromine is a noble gas. False. It is a halogen. Bromine is not a noble gas. Alright, so now we're talking about ions and about determining the charge from the periodic table. I do expect you to be able to do this. It will come in very handy when we get to the nomenclature and writing molecules in the next and last chapter in this exam. So I would suggest memorizing these here. So everything in this column wants to be +1, everything in this one wants to be +2, +3, -3, -2, -1. So what we're doing here, reading elemental symbols and working out how many protons, neutrons, and electrons, there will be at least a couple questions on the exam where you will have to do this exact same thing. The exact same thing we did on the slide here. So if you remember from the video, we worked out how many protons, neutrons, and electrons each of these things had. This ended up having 12 of everything. But then we had other ones over here, like the chlorine had a different number of every single one. You will have to do this on the exam. There will be, I forget exactly how many I usually do, but I want to say it's 3, maybe 4 different elemental symbols that you will need to read, and you will have a spot down below where you can put in the number of protons, the number of neutrons, and the number of electrons. So again, I'm guaranteeing you will have to do this on the exam if you want to get points for those questions anyway. I guess if you are perfectly fine leaving them blank, you don't have to. But if you want the points, you will need to do this on the exam. So make sure you know how to do that. And as far as the atomic weights, so calculating atomic weights using the masses of the isotopes, I'm not going to have you doing calculations for that. So like we did here, where we took the masses and we multiplied them by the decimal form of the abundance, and we added all the isotopes together, and that gave us the atomic weight for that element. I'm not going to have you doing that, but I do expect you to just understand the general concept that the atomic mass is a weighted average. So that's really all I'm looking for here. We're not going to be doing calculations, more just understanding that where we get that number from the periodic table is from looking at all of the different isotopes, and we weight the isotopes that are more prevalent higher than the isotopes where we have very, very little of those present. All right. So then the last one here, last chapter. Chapter 5, Molecules and Compounds. So we started off in this chapter talking about the, going too fast. Talking about elements coming together to make a molecule, and how the properties of the molecule are going to be very, very different compared to the properties of the pure elements, and talking about how we write these formula. So obviously you should be able to read the formula to understand, subscripts are indicating how many atoms are in a molecule. And then, even though we haven't gotten there yet, coefficients out here are going to be how many of the entire molecule we have. I'm not going to have you actually writing formula like this in the exam, mainly just because, once again, there's not really a great way of doing that in Blackboard. If this was an on-paper exam, 100% I would have you writing formulas, because you can write it with your hand. There's no technological limitations there. But doing subscripts and things like that is not the easiest thing to do in Blackboard usually, and sometimes students get confused about that. And so I'm not going to have you writing out formula in Blackboard, but I will have you naming things using formula. So reading a formula and then providing the name, which we'll talk about later in just a minute. So here, this is just kind of talking about different ways of representing molecules. Again, I'm not going to have you drawing or anything like that, any of those. As far as categorizing compounds, really the same thing that we talked about earlier with elements, compounds, homogeneous and heterogeneous mixtures. You should be able to categorize things into these 4 different kinds of pure substances. These I'm not quite as sure that I'm going to have questions specifically on this as I was with the other ones, mainly just because this kind of comes up again with the naming. But it is definitely something that you should be able to do. You should be able to recognize whether you have an atomic element, a molecular element, a molecular compound, or an ionic compound, because you'll need to be able to do that to name stuff later. More specifically, by the way, you should for sure know the 7 diatomic elements. That would be, again, a nice, easy question for me. Just name the 7 diatomic elements, give you 7 different spots to fill something in. So make sure you know those 7. So again, we have hydrogen here, that is 1. And then starting with nitrogen, go over to fluorine, and then down to iodine. Those are your 7. Okay, so this is just more details talking about the different kinds of compounds, molecular versus ionic. Just to remind you, the molecular compounds, these are when you have 2 or more nonmetals and only nonmetals. And then ionic compounds are where we have a metal and a nonmetal. So if we have a compound and a metal is present, it's ionic. We will never have a compound with only metals in it. At that point, that's not a compound, it's just a hunk of metal. And we don't consider pieces of metal to be compounds. So if it's a compound with metal in it, it is going to be ionic. So we got into more of that here, talking about the formulas for compounds. This is definitely something that I'm not 100% sure that I'm going to guarantee this is going to be on the exam, but I would say it's really close to guaranteed that I'm going to put some questions on the exam where essentially I just say if you have, to use the example here on the screen, I might make a question that says if you have a molecule made of magnesium and chlorine, how many of each will you have in the formula? And so I would give you a spot down below where you could say, you know, magnesium, it's going to have 1. Chlorine, it's going to have 2. And so it'll be up to you to figure out those 2 numbers, the 1 and the 2. So you could use the charges to do that. Magnesium is in column 2, so it wants to be +2. Chlorine is in column 17, the halogens, and so it wants to be -1. And so it needs 2 of these to balance out the charge of one of those. So again, I'm not quite so sure as to guarantee I'm going to put it on there, but I'm as close as I can be without guaranteeing it. So this is just, again, a reminder of those different charges that you might see. Alright, so then the final topic here is nomenclature. And you will need to know how to name molecules. I guarantee you there will be a good bit of nomenclature on the exam. I would say something probably between 15 and 20 points of nomenclature. Probably closer to the 15 than to the 20. Something like that. Points worth of nomenclature. So it's going to be a pretty big chunk of the exam. I'm not going to do anything super crazy. It's going to be all stuff that is very similar to what we looked at here. And by the way, if you remember in the dimensional analysis, I said that you could go to the Chem 1 lecture slides to see a more in-depth view of the nomenclature. The Chem 1 slides are going to be the exact same thing here. You might, if you want to hear me explain it a second time, maybe I explain things slightly differently. I honestly don't remember. I don't think I did. But the slides for the Chem 1 stuff is the same here. I don't do the nomenclature different from one class to the other. With the exception, I believe, that I include hydrates. I include the hydrated ionic compounds in Chem 1, and I don't do that here. But of the stuff that is here, I don't believe I do anything different over in those other slides. So if you have questions over how to name any of these molecules, if you're struggling with that, please feel free to email me or to ask me about it if you're going to see me before the exam. But please be sure you are at the very least comfortable, maybe not, supremely confident, but at the very least comfortable with most of these different styles, if you will, of naming molecules. And that really is the thing that you have to figure out, is which one of these methods do I need to use for naming the molecule, because that is the most common mistake I see. Is I will have maybe a molecular compound, like these here. And someone will try to name them using the rules for ionic compounds. Or maybe it'll get flipped, and I'll have an ionic compound and someone tries to name it using the molecular compound rules. So the first and perhaps biggest battle is just figuring out what kind of molecule do I have, and then using the correct naming rules for that molecule. And so if you're confused as to what kind of molecule you have, the key is this top section right here. So if you have a metal and a nonmetal, that is an ionic compound, and so you'll use the ionic compound rules. If you only have nonmetals, that is a molecular compound. You'll use the Greek prefixes, the mono, di, tri, tetra, and so on. And if you have hydrogen and a nonmetal, so hydrogen at the beginning of the molecule where metals would normally be, that is an acid. And so you'd have to figure out, do I have a binary or do I have an oxyacid? And so just figuring out what you have is usually the key to getting the rest of the naming process correct. All right. I know it's a lot. It is a lot. It is a lot of material. But that is it for Exam 1. If you have questions over the material or just questions in general over the exam, and actually just let me, for a minute, talk to you about the exam. I know there's certain questions that normally come up during these types of review sessions. So one of the questions that usually comes up is how many questions will be on the exam. And that's a bit complicated because of the way Blackboard is set up. Like I said before, normally in a paper exam I would have one question with multiple parts, so each of those individual parts would be relatively simple and not very time consuming, but put them all together and it's a normal size question. In Blackboard I can't really do that, and so in a normal exam I might have, I don't know, maybe 12 questions, and at least half of them would have parts. And on a Blackboard exam, because I can't separate the questions out into different parts, every single one has to be its own individual question, it's probably going to end up being, I don't know, maybe 30 questions, something like that. And I know that seems really daunting, but again, many of those questions are very short and simple. Many of those questions, and actually it might even be more than 30, because you would have a question where it's just, here's a symbol, write the name for just one molecule. And if you know the molecule, that is a 10-15 second question at that point. Obviously, if you're not sure and you have to sit and think about it and work it out, it can take a little bit longer. But there will be many questions that are at the very least intended to be very fast questions. So like the classifying matter, if I give you silver, it's like classify this as either an element, compound, homogeneous, or heterogeneous, and the thing I give you is silver. Like that shouldn't take very long to work out. Silver is an element on the periodic table, so you pick element and you move on. So there should be quite a few questions like that where it's meant to be relatively fast. If it's something that you're kind of stumped on at first, you can always leave the question and come back to it later. So if you start the exam and you see a large number of questions, don't freak out. Again, most of those questions are going to be really short. There's really not any questions that are intended to be long questions. If you were in my General Chemistry 2 class, who are going to be taking their own exam around the same time, they do have questions where the question is intended to take several minutes to solve. I'm not going to have any questions on this exam where the purpose, I go in writing the question knowing it's going to take several minutes to solve this. Now, if you have quite a few questions on this exam, and it takes you several minutes to solve some of them, congratulations, you're human. Everyone is going to have some questions that they struggle with. But I'm not writing them intending for people to struggle with them and to take a significant amount of time. In other classes that I go in writing it, not intending to be difficult, but intending for it to take some effort, to take some time. It's not something you can just look at and figure it out. So all that being said, I do try to limit the number of questions so that if you're going through the exam and you don't struggle with any of the questions, which again you should. Again, since I've been teaching it for so long, I don't struggle with any of them. I write the questions. But even if you're someone that is very, very good and understands the chemistry and everything, you're probably still going to struggle a little bit with a few of the questions. But if you don't, you should be able to finish the exam in probably half the time that you're given. That is usually the way I write exams. I try to time them out where if you just work through at a normal pace, you don't get stumped on anything, you just work through and you get it done, you should have at least half of the time left when you get to the end. So you will have 80 minutes for this exam. It should take you, if you're not hurrying, if you just think about each question and give it a thoughtful answer and you work through the math, it should take about 40 minutes. And so you should have at least 40 minutes of time to work on stuff that is stumping you, stuff that you're struggling with. You should have about half of the exam period to work those things out. Let's see, what other questions? Other things that people ask about. For some reason, nothing's coming to mind. Just a few other technical things, I guess, about the exam. I'm going to make it available at the testing centers all of next week, so that would be the 21st through the 25th. It will be available for that whole time period, but you will only be able to go in to take it during the times that the testing center is open. And you will have to set up an appointment. You cannot walk into the testing center to take the exam. You must call beforehand or email beforehand and set up an appointment to do that. And I believe if you go up here, let's see, yeah, so right there, testing services. There is a whole bunch of links here, so you can set up appointments from that link there, and you can look up the hours here and locations. I believe all the campuses are open at this point. For a while, West was not open, but I believe West opened last week. So you should have access to all of the testing centers, but just keep in mind they don't all have the exact same hours. So again, you must set up an appointment to go and take the exam. And I think that's it. I think that's all I'm going to say. It's been a long video, but there's a lot to talk about here. If you have any questions, feel free to email me. And if not, I will see you all next time.